Hi everyone, I'm Roxane Fischer, CEO and co-founder of AnyShift, and today I'm very excited about speaking about the importance of context when it comes to your production systems, and especially context with a graph, a knowledge graph, when you speak about infrastructure and production system, and happy to deep dive into it. First of all, I just want to present myself. I'm one of the two co-founders of AnyShift. We build AI on-call engineers. So we are going to streamline debugging and find the root cause analysis when you have like complex systems, production systems between different sources of data. And we actually build this graph, this context engineering for your infrastructure. And today I'm not exactly going to speak about our product layer at AnyShift, but more about the tech that we create underneath, which is this graph. To illustrate the point and the importance of context and graph databases, I'm going to use the first example on how the context and why it is so important to have one when it comes to infrastructure. The first one I'm going to take is going to be about infrastructure as code generation and why it falls short when you don't have the right context. Over the past years, models have become extremely good at generating code, but when it comes to infrastructure as code, it often falls short, or like there's some limitation, and I'm going to try to explain why. The example I'm going to take here is going to be a very simple example for anyone who is familiar with infrastructure, and for the one who are not, let me explain. When you deal with infrastructure as code, you're going to deploy infrastructure with code files. And one of the framework that is one of the most well-known is Terraform. An easy thing that you could ask a junior developer, or like at least depending of like how sensitive infrastructure is, to create a VPC peering connection in Terraform to actually create a peering between two VPCs, your own, your company one, and an external one, which could be something that is done as code through Terraform. So let's see how it goes depending of how you try to complete this task. What I'm showing here would be a piece of code which could be written by a junior developer. No AI, simple, kind of very use case with bad practices, where you can see here that the VPC peering between two VPCs is going to be hard-coded by the developer. It got through the AWS console or any kind of console, so different IDs, and going to create the connection. This is very bad practice because you are going to create hard-coded values, which can break dependencies when your infrastructure gets more and more complex. So now let's see how the same task would have been done by an LLM, let's say GitHub Copilot. What you can see here is that with the latest changes and updates of LLMs, the quality of the outcome would be pretty good. And GitHub Copilot, for instance, will know that it cannot do hard-coded values, but should use dependencies. In this case, it would be the best practice, but it misses the real value to make the connection. What GitHub Copilot will try to do next is to then take into account like those missing values and try to create them. Because it doesn't have the context of what the idea of my VPC is, or where it is defined in another repository, it's going to try to create a new one, which is realistic in terms of code, but completely not realistic. And in this case, because it didn't have the context of my entire infrastructure, which can be huge, the LLM falls short. Now the question is, can a cursor or any AI IDE can do it? Normally, such IDEs take into account multiple repositories and are able to make those connections. In my case, this is what should have been done by Cursor. I've created this new VPC peering connection, and what I want is that I'm referencing for this variable to another repository with my own VPC, with the remote states. The thing is, if I come back to my earlier example, where my junior developer has created in the past, at the beginning of my company, some hard-coded values, in this case, this value is only a value that refers to a cloud resource. It doesn't refer to anything else. In that case, Cursor cannot, in any case, make the connection, the dependency link between this hard-coded value, which is part of my code very often, or when I have like multiple integrated modules, to my remote VPC in another repository. This is the case because Cursor cannot do the reconciliation between cloud data and code. It doesn't have the context. I'm actually going to skip the live demo and speak straight away about how we could get this context through a live knowledge graph. First of all, just to give some context, a graph database is another structure, database structure, which is not sequential, which under a graph actually can represent different entities through nodes and edges. In the case of your infrastructure, it makes total sense because your infrastructure is a graph and your nodes represent different entities, VPC, IAMs, nodes, containers, that actually can be linked by different type of connection. For instance, an IAM can be linked to an EC2 instance, and an EC2 instance can belong to a VPC. So that would be a very easy and small representation of your infrastructure as a graph that you can see here that represent different resource instance, service type, accounts, providers, etc. At the end, your infrastructure production systems is a huge monster, which is actually a connection between your cloud providers, Kubernetes containers, code bases, observability data, etc., etc. The more deep and rich this knowledge graph is, the better. Imagine you have all the metadata on top of it. So how is my live data defined in my code base? Who owns it? Who did a commit on it? What is my metadata in terms of like timeline? Then I can ask with AI very deep questions, such as which instances, like EC2 instances or pods, are experiencing high CPU usage over the last 24 hours, and what are the dependencies or service dependencies. And you can go even more deep because you have access to all this information. In reality, your graph, your infrastructure as a graph, is much more complex. So it's even like still a small snapshot of what we do at AnyShift, which is like this representation of a graph, of infrastructure as a graph. And at the end, it can be tens of millions of nodes when you also take versioning into account. To create this graph is complex. How to do it? The first thing to create such context would be to recreate this entire pipeline by using a graph database. We use Neo4j internally at AnyShift. You can use, for instance, Neptune on AWS or other like kind of providers. Once you have decided on your graph database as a technology, you need to define your ontology. Your ontology actually corresponds to how you're going to build this graph in terms of structure, what are going to be the nodes, what are going to be the edges. It's a very complex work because imagine you need to create a common ontology for different cloud providers. You need to have a similar representation for AWS, GCP, and Azure, so your AI will be able to treat them as equivalent, even if the definitions are not the same. Once you have created your ontology, you need to populate this graph. So to do each integration is going to be slightly different. How do you scrap the data? How do you update the graph? And each of them can be taken separately. So for instance, for AWS, you can connect to different APIs, do some scan of the resources, but also like use CloudTrail to have live updated data for like a graph which is super fresh. And this is where the hard work comes from. Having very clean and structured data is something that takes a lot of time, especially when you have like multiple integration and source of information. As written here, it's time heavy and hard to maintain, but gives particularly good context. The other solution, which is also pretty good at some lower scales for startups and scale-ups, is to use MCP servers. MCP servers model context protocols, actually very easy way to connect your LLM to data sources. AWS, for instance, has amazing MCP servers. And by connecting your credentials to those MCPs and using them within your AI tools, AI agents, you can easily get some very useful context to answer to the question that you want to have an answer to, such as what is my live data? What are the resources? What are the resources that are under heavy load or usages? But at the end, this solution, which is really straightforward, will be limited if your infrastructure is too big, because an MCP server is just an API. And each time you make an API call, you can just utilize a limited amount of data. If you really want to understand in one call all the dependencies, all the relationship, all the history on one specific request, you need first to have this huge cache, this huge database of how your infrastructure actually looks. In this example, in this slide, I've actually tried to show how you can build this graph on a subset, on a small example. The example here is how to create a mapping between your cloud data, let's say AWS still in this case, your Terraform state and your Terraform code. The case here is to be able to understand what has drifted in your infrastructure, so what has been correctly defined in your code and what has not been, and which resources in your cloud can be considered as shadow IT or drifted. To do, you need to create reconciliation between the graph in your cloud, so what actually really exists in your cloud, what has been defined in your code, and what is actually like this intermediate cache layer in your Terraform state. To create this graph, you have two steps. First, you need to parse the data, and then you need to populate the graph. So in the first case, you need to parse the data for AWS, for Terraform state, and for your Terraform file, using the different IDs to make some reconciliation and to create some links between the entities. So you're going to use the same idea for your cloud resources in AWS to the Terraform entity in your Terraform state, and then to the Terraform entity with its code definition in the Terraform file. Once you've been able to make this mapping, you need to put it in the graph. You need to build the graph and be able to update it live. But actually, once the first step has been done, the second one is much easier. If the scale of your infrastructure is not too big, and if your amount of change is quite limited. And actually, that's the end in 15 minutes, which was the maximum. But so in conclusion, what I want to emphasize here is that when it comes to your production system, and when you speak about context engineering, context is key, and it should be represented as a graph. Your different services, everything that runs within your infrastructure and your application can and should be represented as a graph, which is way more dense in information than just a relational database. The ROI can be direct because we really need, when we speak of AI, to have this context to create some quality code and quality debugging. And that's it for me. Thank you so much and have a great day.